Students, we were discussing sums from the section oscillations. We have discussed 8 sums. Now we will start the ninth sum that you can see from the attachment. Alright. Dictating the question once again. The time displacement equation for a SHM is given by x equal to a sine within bracket omega t plus theta. Now show that the velocity v and acceleration a are related by omega square v square plus a square equal to big A square omega square. This is your acceleration, the small a, and the big acceleration and the big A means your amplitude. This you have to prove that. Alright, I'm writing PT in short, the proof that. Alright, so okay, let's start. Your x value is given. The general form of writing the displacement equation is this. Okay, so from this part we can easily find out the value of v. What is the value of v? It's dx by dt. So do the differentiation with respect to x. You will get a omega cos omega t plus theta. Okay, so velocity is done. Let's move on to the acceleration part. A equals to what? It's dv by dt. Alright, so again differentiate this equation with respect to time. So minus a omega square sine within bracket omega t plus theta. Alright, so a and v calculation is done. That is your acceleration, a, small a. Now let's go back to the prove that equation. So in the LHS part, what it's written? Omega square v square plus a square equals to omega square. Students, let's keep omega square as omega square only. Okay, keep it as intact. So I'm writing here omega square into, let's put the value of v here. The value of v here is given. Okay, the first derivative. So put the value of v here. So it's a omega cos, let's put it as in the second bracket, cos within bracket omega t plus theta square. Okay, this is your v part, omega square v square part, plus what you have to write, the a square part. A square means your accelerations part square, so that means plus again minus a omega square sine within bracket omega t plus theta. Okay, so our main part is done. Alright, this is just the mathematical part. So if you just open out the back bracket, it's a square omega 4. This is basically maths part, so no physics is here. Omega 4 you will get if you just do the multiplication. Square cos square you will get within bracket omega t plus theta as usually, plus sine square again from this term, sine square omega t plus theta. Okay, I'm writing here. Okay, so this is resembling what? Sine square theta plus cos square theta, which is equal to 1. So it is, the final step is becoming this a square omega 4. Understood? Very easy one. It also came in one of the early ages. Okay, very important type. Now students, let's discuss one more sum. Alright, okay. So this was your sum number 9. Your question number 10 is dictating the question, don't worry. What is the displacement of a particle in AC chain from its equilibrium position when its kinetic energy is 1/2 of its maximum kinetic energy? Alright, this is your question number 1. Okay, so yes, similar sum students we did it previously also. That means your displacement, you have to find out the displacement of the particle. Okay, at the time when the condition is given that your kinetic energy should be 1/2 of its maximum kinetic energy. Alright. So okay, so students, if the displacement of a particle in acceleration from its equilibrium position be x, if we denote it by x, alright, as usually, so then its kinetic energy value will be what? Considering x to be your displacement of the particle from its equilibrium position, I am writing here displacement and in short. Okay, so your value of k will be half m omega square within bracket a square minus x square. This is the formula we have studied. Okay, now if you consider x to be as 0, okay, your x is becoming 0, then what value of kinetic energy you will get? So your ke will become half m omega square a square. Clear? So this is the basic part that we have to do for this question. Now what is the question number 1 given? That you have to find out the displacement when k is becoming half of its maximum k. So from the problem we can write half m, that means we are writing this part, half m omega square within bracket a square minus x square is equal to half of its maximum acceleration. So half of its maximum acceleration value is what? Half into m into omega square a square. That means I am writing this part, this particular term I am writing from this one. We have already calculated. Okay, if x equals to 0, you will get this particular equation. Alright, so since it's given in the question that you have to find out the value of k when it's becoming half of its k. So if you just calculate, students, so this is our final equation, students. Now if you just calculate, students, you will get the value of x as plus minus a by root 2. Okay, this is basically the maths part, this full equation, solving the equation part. Okay, this you can do it on your own.